Okay, everyone, I think we'll go ahead and get started. Well, good morning. And welcome to this special event held as part of the Ideas Festival, which is the centerpiece of Purdue University's Giant Leaps Sesquicentennial campaign. As Dean of the College of Veterinary Medicine, I am pleased to welcome you to this presentation about a very significant and I think timely topic. In addition to 2019 marking Purdue University's 150th anniversary, this year also is the College of Veterinary Medicine's 60th anniversary. In honor of these two significant milestones, our college is pleased to bring you today's very special speaker in partnership with our co-sponsors, the Department of Public Health and the College of Health and Human Sciences, and the Indiana University School of Medicine, West Lafayette campus. I'd like to acknowledge Dean Marion Underwood of the College of Health and Human Sciences, who is here with us this morning. Our college also enjoys a great collaborative relationship with the Purdue College of Pharmacy, and we are pleased that Pharmacy Dean Eric Barker has joined us as well. Several College of Pharmacy students will be assisting us a little later with a surprise component of this morning's event. The Ideas Festival involves a series of events designed to connect world-renowned speakers and Purdue expertise in a conversation about the most pressing problems facing the world. Four themes characterize the focus of the Ideas Festival. And the theme that today's presentation aligns with is health, longevity, and quality of life. That theme is particularly relevant to the College of Veterinary Medicine and our co-sponsors. And the topic of today's presentation involves a highly relevant issue in the 21st century. What if the next pandemic is inevitable? I want to add that not only are you about to hear an exceptional presentation on this topic, you're also invited to stay for a very practical demonstration on stage afterward involving myself and our distinguished guests. A related clinic also will be set up to serve you just outside of Lowell Playhouse after the talk as well. And then you're also invited to join us for a panel discussion this afternoon titled The Current and Future Role of Vaccination in Global Health, which will be held in Lynn Hall beginning at 1:30 this afternoon. But more about that later. It is now my distinct honor and privilege to introduce this morning's special guest speaker, Gina Kolata, New York Times science journalist and author of the book Flu, the story of the great influenza pandemic of 1918. In her book, Gina Kolata recounts a fascinating story of one of the world's deadliest diseases. She draws from her extensive research and relates it to current illnesses as she tells the story of this discovery and explains what it revealed about the 1918 flu and its destructiveness. Gina possesses a rare combination of dedication as a scholar and talent for addressing scientific subjects in a way that captures the attention of the public. She has appeared as a guest on Charlie Rose. She's joked with Stephen Colbert and lectured at Yale. Her work as a reporter for the New York Times resulted in her receiving the Pulitzer Prize, not once, but twice, for investigative reporting and for explanatory journalism. Gina has authored a total of 6 books, including such acclaimed and best-selling titles as Clone, The Road to Dolly and the Path Ahead, and Ultimate Fitness, The Quest for the Truth About Exercise and Health. In addition to the Pulitzer Prize, Gina's awards and honors include recognition by the American Association of Healthcare Journalists, the University of Maryland, which gave her its Distinguished Alumnus Award, and Bowdoin College, which awarded her an honorary doctoral degree. She also is the recipient of the Susan G. Komen Foundation's prestigious Media Award for reporting on women's issues and breast cancer. Gina studied molecular biology on the graduate level at MIT and has a master's degree in applied mathematics from the University of Maryland. So please join me in welcoming Gina Collada.
Thank you, Dean Reed, for that wonderful introduction. Can I just make one little correction so people don't think I'm exaggerating my credentials? I actually was a runner-up twice for the Pulitzer. Didn't actually get it, but I was honored and thrilled to be a runner-up. I don't want anybody to think I'm lying or something in my CV. Maybe my Speakers Bureau was making it up or exaggerating a little bit. I'm really thrilled to be here, and I'm really honored. And Dean Reed told me that that I was invited because he read my book, which makes me even happier as an author. And I really like state land-grant universities. I went to one, the University of Maryland, and when I came into this university's campus, it just sort of reminded me of Maryland, the red brick buildings, the mall, the students. So I feel like I'm at home here. This is my kind of a place. But I also have this real passion for science reporting when there's an amazing story to tell. And to me, the story of the 1918 flu is one of the most amazing stories. When people say, what are some of your favorite things that you've worked on? I say, this story of this flu and how they found the virus is truly so astonishing that if somebody tried to tell it as a novel fiction, people would say it kind of defies belief. So let me start out and tell you this story. It began 100 years ago. I think I want to move this one forward and then go back to this. There we go. Began 100 years ago when the world was racked by an epidemic of influenza that wreaked devastation so horrific, it's just almost impossible to imagine. If a similar epidemic occurred today, it would kill more people in a single year than all the major killers combined: heart disease, cancer, strokes, chronic pulmonary disease, and Alzheimer's disease. It came at the end of World War I and killed more Americans in a single year than died in battle in World War I, World War II, the Korean War, and the Vietnam War. It's estimated that 50 to 100 million people died around the world. It's actually considered the deadliest event in human history. Then the virus disappeared. It just vanished from the face of the earth. And there seemed to be no way of finding it, no way to study it to figure out why it was so deadly. It was just gone. There are no fossil viruses. You can't find a virus's DNA on the bones of a person who died decades ago. And against all odds, two unlikely people pulled off the seemingly impossible feat of finding the 1918 virus. It was fragmented, broken into hundreds of pieces, but there is no doubt that what they found was the real thing, and they were able to figure out its genetic sequence. That, to me, is one of the most remarkable science stories ever. I'm going to tell you the story of how these two people found that long-ago virus. It is, as one of them, molecular biologist Jeffrey Taubenberger, put it, a medical detective story. He said, here was a mass murderer that was around 100 years ago and who's never been brought to justice. And what we're trying to do is to find the murderer. But first, a little context and a few tales of horror. The 1918 flu was 25 times more deadly than ordinary influenza. It killed 2.5% of its victims, as compared to the usual 0.1%. So many died that the average lifespan in the U.S. was dragged down in 1918 from 51 years to 39 years. So you can see this little peak on the risk of death in the United States. You can see the blue peak, that was the 1918 flu. But then there's another interesting thing about it, which this graph also shows you. Ordinary flu viruses are most dangerous to the very young and the very old. This flu, though, preyed on the young and healthy, parents and young adults. And you can see that in that picture. For those who it killed, death came quickly. A flu victim's face would turn dark brownish purple. The person would start to cough up blood. Feet would turn black. A blood-tinged saliva would bubble from the victim's mouth. The person would die by drowning as the lungs filled with a reddish fluid. And if a doctor did an autopsy, he would see the person's lungs lying heavy and sodden in the chest, engorged with a thin, bloody liquid, useless, like slabs of liver. The flu, though, despite claims to the contrary, did not start in one place. It erupted simultaneously around the world between July and September of 1918. It's now thought that somehow the flu sort of was seeded silently around the world and suddenly just sort of erupted, which is kind of weird right there. One of the first places that was known in the United States to have had the flu was Camp Devens. Go back to this. Which is a military base near Boston. One way we know what happened there in September of 1918 is because a young doctor, and all that's known as his first name, Roy, wrote a letter that was discovered more than 60 years later and published in the British Medical Journal in 1979. Someone actually found his letter in an attic. Roy told of a horrific scene. "It takes several trains to carry away the dead," his letter said. He continued, "For several days there were no more coffins and bodies piled up something fierce. And we used to go down to the morgue and look at the boys laid out in long rows. It beats any sight they ever had in France. An extra long barracks has been vacated for the use of the morgue. And it would make any man sit up and take notice to walk down the long lines of soldiers, all dressed and laid out in double rows." As news of the devastation spread, the Surgeon General sent 4 eminent doctors to Camp Devens to report on what was going on. One of them, Victor Vaughan, had been president of the American Medical Association. He was horrified, writing that his memories of what he saw at Camp Devens are ghastly ones, which I would tear down and destroy were I able to do so. He wrote that he saw hundreds of stalwart young men in the uniform of their country. They are placed on the cots until every bed is full, and yet others crowd in. Their faces soon wear a bluish cast. A distressing cough brings up the blood-stained sputum. In the morning, the dead bodies are stacked about the morgue like cordwood. This picture was painted on my memory cells at the Division Hospital, Camp Devens, in the fall of 1918, when the deadly influenza virus demonstrated the inferiority of human inventions in the destruction of human life. Soon the flu had spread to every corner of the country and nearly every nation, and I will show you some pictures of the flu. People everywhere were ordered to wear gauze masks when they left their houses. Schools, courts, and movie theaters were closed. Doctors were at a loss to give advice. Scientists knew there was such a thing as a virus, but no one had ever isolated one, and it was not even clear that a virus caused the flu. Some thought it was bacteria. Doctors tried to protect people with what were actually useless vaccinations made from the body fluids of patients. Entrepreneurs peddled useless elixirs, and panic spread. Dr. Vaughan said it best. The epidemic, he wrote, encircled the globe, visited the remotest corners, taking its toll of the most robust, sparing neither soldier nor civilian, and flaunting its red flag in the face of science. And then it was gone, nearly forgotten. No one even thought to search for that deadly virus, because how would they? The virus died with its victims. Until, nearly 80 years later, the virus was found. The clues to solving the murder mystery came in the form of 3 of the flu's victims. They did not know each other and were simply 3 among millions who died of the flu. One was Roscoe Vaughn, a 21-year-old private in the Army. Another was Private James Downs, age 30. And the third was an obese woman, and the fact that she's obese is important, I'm not just saying that, who lives in a remote Alaskan village. Roscoe Vaughn got the flu at Camp Jackson, 7 miles east of Columbia, South Carolina. He was sent there for artillery training along with 43,000 other young men at the military base. When the flu struck that base, the young soldiers were hit hard. In August of 1918, 4,807 soldiers were admitted to the camp's hospital sick with the flu. The next month, the number was 9,598. One young doctor there said he actually saw men drop dead as they walked across the paths of the camp. He himself tagged 30 corpses in one day. Private Vaughn fell ill the third week of September. He reported for sick call on September 19th. At 6:30 a.m. on September 26th, he died, gasping for breath. At 2 p.m. on the day of Private Vaughn's death, an Army doctor did an autopsy. He wrote that Private Vaughn was a bit chubby, but his muscles were in good condition. But when he died, he had about 1.5 cups of clear fluid in his chest cavity, and over the entire surface of his left lung were small seepages of blood, ranging in size from a pinhead to a dime or larger. The air sacs in his lungs were clogged with fluid. As part of the autopsy, the doctor cut off a piece of Private Vaughn's lungs, soaked it in formaldehyde to preserve it, embedded it in a chunk of candle wax the size of a thumbnail, and sent it to Washington, where it was stored in a small brown box on the shelf of a vast government warehouse. The second victim, who will be crucial to our story, is Private James Downs. He got the flu at Camp Upton in New York. The flu struck Camp Upton at the same time as it struck Camp Jackson. 1 out of every 10 men at the camp was admitted to the camp hospital. Private Downs was among them. He was admitted on September 24, 1918, delirious with a temperature of 104 degrees. 3 days later, at 4:30 a.m., Private Downs died of the flu, 2 hours before Private Vaughn in South Carolina died. That same day, an Army doctor performed an autopsy. Private Downs was 6 feet tall, weighed 140 pounds, with, the captain wrote, no external signs of disease or injury. But his lungs were filled with fluid, and what the captain said was a bloody froth exuded from them. The captain cut a small slice from one of Private Downs' lungs, soaked it in formaldehyde, encased it in wax, and sent it off to the same government warehouse. And there the lung tissue taken from Private Vaughn and Private Downs remained, untouched and of no interest to anyone. They were just 2 snippets of tissue among the pathology tissues from millions of people who died from diseases rare and common. The Alaskan woman who provides the third piece of evidence in our story lived in a tiny village of just 80 people on the flat frozen tundra of the Seward Peninsula. The nearest town was Nome, 90 minutes away by dog sled. She, like the other villagers, lived in a soot-filled igloo with a window made of seal gut. We don't know her name or anything else about her. Did she have a husband, children? No one knows. On the last Saturday in November, 2 visitors from Nome attended a crowded standing room only service in a chapel run by Lutheran missionaries. 2 days later, the first villagers fell ill with the flu. 2 days after that, the first flu victim died. Soon the death toll reached 72. 72 out of 80 adults in the village were dead. The igloo contained 25 bodies of flu victims. By the time the 3 weeks long epidemic left that tiny village, only 5 adults were still alive. 46 children were orphaned. The bodies piled up. They needed to be buried, but that was not easy. There were only 5 adults left, and the ground was frozen rock solid. Men from a nearby village arrived to help. In order to dig into that hard, frozen earth, They pumped hot steam into the ground, which enabled them to dig a trench that was 30 feet long. They buried the flu victims there in that common grave, marking each end of the grave with a white cross. The obese woman was buried there with the others, and there her corpse remained. The next chapter in our story begins in 1950, when a 25-year-old Swedish medical student arrived for a study program at the University of Iowa, looking for adventure. He found it by accident when one day his lab hosted a well-known virologist from Brookhaven National Lab, William Hale. Over lunch, Hale made an offhand remark about the 1918 flu. He said, "Everything has been done to elucidate the cause of that epidemic, but we just don't know what caused that flu. The only thing that remains is for someone to go to the northern part of the world and find bodies in the permafrost that are well preserved and that just might contain the influenza virus." Halton was transfixed. He would do just what Hale had suggested, he decided, and he knew just how to do it. The summer before his stint at the University of Iowa began, he and his wife had traveled to Alaska and met a paleontologist, William Geist. They had spent weeks on digs with him. Geist could help him find villages that had been decimated by the flu and could introduce him to villagers who might consent to having their relatives' graves dug up so Halton could look for the still frozen flu victims. It took quite a while, planning the trip to look for graves in the permafrost, writing letters, traveling to Alaska to places that looked like they might be promising but were not. Finally, Halton came upon the tiny village of Brevik, the one where just 5 adults out of 80 had survived the flu. The victims were buried 6 feet underground. Halton spoke to the village council and asked their permission to exhume the bodies. "If you allow me to dig in the grave, I will do my best to find some specimens. And once we have the virus, we can produce the vaccine. And the next time the disease comes around, you'll be immunized and you will not die." They agreed, and Halton began the arduous task of digging. Now, I think I have a picture of him in, whoops, this is what the virus looks like. Sorry, I'll go back to that again. Okay, there they are on his first trip to Alaska. It's Halton in the middle. They agreed, and Halton began the arduous task of digging. 4 days later, he came upon his first victim, a little girl with black hair and braids tied with bright red ribbons. Halton called for help from a team of scientists in Fairbanks. They arrived 2 days later. Halton and the others kept digging and found 3 more flu victims. At that point, they stopped and cut 2-inch cubes of tissue from the frozen victim's lungs. Somehow, they gave no thought to the risk that perhaps the frozen tissue contained intact viruses, and perhaps they might be exhuming viruses that, when thawed, could once again infect the world. In 1951, I was a graduate student, Halton told me. I just didn't have enough knowledge of how things spread. I mean, to this day, that kind of shocks me, but that's what he really didn't think about it. He returned to the University of Iowa and began his work. He ground up the lung tissue, suspended it in a salt solution, and whirled it in a centrifuge to separate the viruses from the debris. He added an antibiotic to the virus-containing fluid to kill any bacteria that might be present, and then began the tedious task of injecting the fluid into fertilized chicken eggs, which is how flu viruses were grown. Every morning, he woke up and rushed to the lab to see if he had any viruses in the eggs. If he did, the fluid surrounding the chick embryo would be cloudy. But day after day, every egg had only clear fluid. Then he tried squirting the flu liquid into the mouths of lab animals. Nothing happened. Before long, he'd used up all of his material. The virus was dead, Halton said. He never wrote a scientific paper about his failed attempts. Instead, he stayed on in the U.S., finished medical school, and entered private practice as a pathologist in California. And he bided his time. Science was not yet ready to isolate the 1918 flu from those victims buried in permafrost. But when it was, Halton knew how to find them. I knew that one day I would have another chance, he said. That chance came 40 years later. The next chapter of our story begins in the winter of 1995. Now, I think I have a picture of, where's Taubenberger? Sorry, I'm not good at this. There he is. Next chapter of our story begins in the winter of 1995. A little known young scientist at the Armed Forces Institute of Pathology had a brilliant idea. In molecular biology had advanced to the point at which scientists could isolate genes from preserved tissue. He knew about a treasure trove of preserved tissue, an entire warehouse of tissue. It was part of the Armed Forces Institute of Pathology. There it is. And it had been established by President Abraham Lincoln. Lincoln had ordered that every time a military doctor examined tissue from people who died or people who had tumors or other illnesses, the doctor had to send a snippet of tissue to the Armed Forces Repository. In 1995, the warehouse contained millions of scraps of tissue, preserved in thumbnail-sized blocks of paraffin. It was the Library of Congress of the dead. Taubenberger could look for genes in those tissues. The only question was, what gene would he look for? Meanwhile, maybe he could look at the genes of someone famous, he thought. Or perhaps he could figure out a genetic question involving yellow fever victims. Finally, it came to him, the 1918 flu. Maybe he could find lung tissue from flu victims. We'll go back to Taubenberger. And if he found some lung tissue from those victims, maybe he could pull out the 1918 virus. He knew it was a long shot. The records of everyone whose tissue was stored in the warehouse from 1917 on were available on computer files, 3 million specimens. But it was possible that there were no lung samples from the victims of the 1918 flu. It was wartime. Many who came in to do autopsies were not trained pathologists. And why would a pathologist, in the midst of a terrible epidemic that also took place in the midst of war, take the time to send a lung sample to the Armed Forces Institute of Pathology? But it seemed worth a try to find such a specimen. Taubenberger planned his strategy. He would search for people who died within a few days of becoming ill. If they died later, they might have gotten a bacterial infection on top of the flu, and the flu virus might be gone from their lungs when they died. He put in a request at the warehouse. An answer came back. 6 specimens met his requirements. Taubenberger got the paraffin-encased tissue and began his search for the virus along with his colleague, Ann Reed. But their work was getting nowhere. With the methods used at the time, and this was like the mid-1990s, so molecular biology wasn't where it is today, Taubenberger and Reed saw no evidence of virus in the tissue. They kept at it, asking if they could hone their technique enough to get virus fragments out of tissue from more recent flu victims. If they could, that would at least show it was possible. Finally, more than a year after Taubenberger's initial request for the lung tissue from 1918 flu victims, he and Reed managed to show they could do the work. They got flu virus from lung tissue taken from a more recent flu patient. So they went back to the tissue from the 1918 flu victims and began trying to extract the genes and figure out their sequence. In October of 1996, Taubenberger and Reed had managed to get the sequence of one of the flu genes from the virus in the lung tissue taken from Roscoe Vaughan. It was an important gene called hemagglutinin that is part of the shell encasing a flu virus. It's one of the 2 genes the immune system sees when a person is infected with a flu virus. So Taubenberger and Reed wrote a paper and sent it to the journal Nature. Nature sent it right back to them, rejecting it without even sending it out for review. Ordinarily, scientific journals ask 2 or more experts to give an opinion before deciding whether to accept or reject a paper. Nature apparently decided it was not worth reviewers' time even to look at Taubenberger's paper. Then Taubenberger sent his paper to the journal Science, which also rejected it without review. But the only thing I can assume is they must have thought this was so crazy it couldn't be true. I mean, it's, it's such an amazing thing to say, I got the virus, I got a gene out of the virus, the 1918 flu. They must have thought this must be some sort of a kook who's making all this up, because otherwise you'd think at least they'd review it. But he got lucky at Science, because the senior editor, Eleanor Butts, there, intervened on his behalf, and the journal decided to send the paper to reviewers. The reviewers were enthusiastic. Finally, in March of 1997, his paper was published in Science. Taubenberger continued to work, but it was so difficult with the methods at the time. It was beginning to seem like there was just not enough material in Roscoe Vaughan's tissue sample to get much more flu genetic material. So he went back to the warehouse and got another sample, this time from James Downs. Then one day, a letter, and you can tell this is mid-90s, a letter, not an email, arrived. I mean, really, when do we get letters, right? Arrived at Taubenberger's lab. He opened it. It was from a 72-year-old retired pathologist in San Francisco, Johann Hulton. He's our guy, as you might remember, that went to Alaska in the 1950s. Taubenberger had never heard of Hulton, but he read his letter with growing fascination. In it, Hulton carefully described what he had done in 1951. He had gone to Alaska and exhumed the still frozen bodies from a mass grave of people who died from the 1918 flu. He had tried but failed to resurrect the virus. Hulton explained that he still had contacts in Alaska and could return there if Taubenberger thought he could use the tissue. He would pay for the trip himself. No need for government funding. He would tell no one but Taubenberger, so there would be no public debates about whether such an expedition was ethical or safe. Please go ahead, Taubenberger told Hulton. He was astonished by Hulton's response. I can't go this week, but maybe I can go next week, he wrote. I'll call my travel agent to fix me up with tickets. Hulton traveled alone, making only one phone call in advance to the city clerk. Was the grave still undisturbed, he asked, and where could he sleep? The grave was undisturbed, he was told, and he could sleep on an air mattress in the schoolhouse. So he arrived. The village council gave him permission to dig. 4 young men were recruited to help him. On the third day, they came to the first body. It was a skeleton. The victim's flesh had decayed after the grave was exposed during Hulton's first dig. A few hours later, though, they came upon an obese woman. Her body was partly decayed, but her lungs were still frozen and preserved. On either side of her were skeletons. Why her, Hulton asked. Then it came to him. Her fat had insulated her body, protecting it somewhat from thawing. See, I told you the obese part there was a reason for saying obese. Here he is on his second trip, a lot older now, 72. He cut out her lungs and sliced them with his autopsy knife. He placed them in a preservative solution that Taubenberger had given him, and he decided to discontinue the dig. Other than the obese woman, all the victims he found were skeletons or badly decayed. Hulton returned to San Francisco with his precious cargo, the lung tissue. Then he sent his samples to Taubenberger. Worried about losses or delays, he sent one package by FedEx, one by UPS, and one by the U.S. Postal Service's express mail. They all arrived, and the rest is history. The obese woman's lungs contained fragments of the 1918 flu virus. Taubenberger confirmed that they were exactly the same as the flu he isolated from the 2 soldiers. And eventually, scientists had the complete sequence of the 1918 flu. So let's go back and look at that. Sorry, my slides are not in the greatest order. That's why I keep switching around here. Where are they? I have a picture of that flu. There it is. It only has 8 genes, so you'd think, this shouldn't be all that hard. But actually, and it turns out that this virus is sort of the progenitor of all the type A viruses that circulate today. It's changed over the years, so it's not as deadly as it was in 1918, but it's still there. I mean, its ancestors are still infecting us. So Jeff Taubenberger's moved to a more prestigious lab now, because he's no longer sort of this non-entity at Walter Reed. He's now at the National Institutes of Health, and he works primarily on developing a flu vaccine that would protect against all strains of the flu with one shot. That tissue warehouse at the Armed Forces Institute of Pathology is closed. I was really shocked. I have no idea why they closed it. It seems like it's an important repository, but it's closed down now. But scientists have learned something about why the 1918 flu virus was so deadly. So here's some of the key findings. One of the flu's proteins, the hemagglutinin, remember I told you that was one of the ones that was on the outside, the shell of the virus that your body recognizes. That acts as a virulence factor. People still don't understand why that particular sequence of that protein makes the flu so deadly, but it seems to be a key to the virus's virulence. It also looks like that same protein from the 1918 virus causes fluid to fill the lungs, eliciting a strong response from the immune system, which can further damage cells that line the lungs. That, in turn, sets the stage for bacteria to invade the lungs. And Taubenberger found that in mice, the virus and the immune system's response made a type of bacteria that often caused pneumonia in 1918 flu victims more deadly. When that happened, the animal's lungs filled with blood clots. That observation could explain the horrific pathology findings. Lungs filled with frothy fluid and clots on the lining of the lungs. And then Taubenberger wrote just very recently that what we know, too, is that these people in 1918 who died didn't die of the flu. They died of one of three types of bacterial pneumonia. Remember, I just said that the bacteria start invading the lungs. And he said, so we have effective treatments for the three predominant bacteria of 1918, antibiotics, and for many other pathogenic bacteria as well. But he says a still unresolved critical problem is the progression from typical influenza to explosive bronchopneumonia may be so rapid that only very early detection and treatment can be life-saving in a modern pandemic of 1918 severity. As many as 2 or more million Americans could die in the span of a few weeks without early diagnosis of impending bronchopneumonia. We also have moderately effective influenza vaccines, he says, and we can produce a vaccine within 6 months. But of course, if a virus like the 1918 virus is spreading around, 6 months is kind of a long delay. He says we also have pneumococcal vaccines and public health recommendations to use them. And then he says we also should be developing, it should be a priority to develop vaccines against the other kinds of bacteria that were invading the lungs of the 1918 flu victims. But then we still have this central mystery of the 1918 virus. Why that flu virus? Is there something unique about it that made it more deadly than others? Can scientists recognize its deadly features if another virus developed it? So far, the answers, according to Taubenberger, who is my expert on this, is that we are no better at predicting the emergence of a new pandemic flu epidemic than we were in 1918. But one thing that's changed is if people could be found, if another virus like this does come back, and if people were detected early enough who were getting the pneumonia, they should be able to survive the flu. So that if we're lucky, because you would require hospitalization and maybe a ventilator, but if we're lucky, if it comes back, it may not be quite as bad as it was last time. So I want to thank you all again for inviting me, and I would be more than happy to take questions. Thank you so much.
Questions?
Yes?
Microphones are down here. Can you please come to the microphone?
Other than pneumococcus, what were the other secondary bacterial invaders?
Okay, so here's what he says. Okay. I'm trying to find it in his paper. Can I get back to you? I don't want to search through while you're looking there, but that's actually a really good question, and I don't know the answer. So I'm sorry, I can't answer the first question we get. Others?
I'm going to ask a question while others are thinking about this. So I have read various estimates of how many people actually died. Estimates that I have read, it ranges from 20 million, 50 million, and one recent estimate I heard was 100 million people worldwide. Can you comment on that?
Yeah, I'll go back to this very recent paper from Dr. Taubenberger, who said that he says 50 to 100 million people, and that may be an underestimate because the flu was really all over the world, and in many countries there were really no estimates of the deaths. They were just sort of, dropped from history. So it's very hard to know, but he says 50 to 100 million is a conservative estimate, he says, which is kind of shocking to think of that happening.
Hi, if I could be permitted a couple of comments rather than a question per se. One is just that the viruses that are likely to be causing the greatest harm to humans are ones that are recent imports from other animals. And that's part of the story of Taubenberger, which is that the 1918 influenza seems to have come more or less directly over from the birds into humans. And that's why, that's where the greatest risk of pandemic is from ones that are recent imports from, direct imports from other animals. But the other thing is the 6-month delay for production of vaccines. We can substantially decrease that nowadays. Newer technologies, cell culture, mammalian cell culture-based technologies can really close that gap. The problem that we have is actually delivery of new vaccines to the population. We don't really have a dedicated mechanism for delivering them to the population in an effective fashion. One of the things that we've got out of the habit in this country is school-based vaccination. When I was a child, we had a number of our vaccines delivered at the school, and that's very important for intervention for this type of flu because two things. One is that children tend to spread the flu much more effectively than adults do. The number of people who will be infected by any particular infected child is at least twice someone who's an adult. But the other reason is that they frequently have subclinical infections and they continue to go to school and so on and continue to spread it. And a school is an organized place where you can deliver this. So it's not just a scientific issue, it's also a societal issue, how we can prevent these pandemics.
Those are really great comments. Thank you so much. And it's interesting. I'd forgotten when I was in school we got vaccinations too. But now it's funny with flu vaccines. So many people say, "Oh, I never get one because I don't get the flu," or the vaccine gives you the flu. And even if you point out that the flu virus is dead in the vaccine, they still say, "Oh, well, I got the vaccine and then I got the flu right afterwards." And the other thing is, of course, the vaccine is not, they never seem to cover all the strains that are out there that year. So people say, "Well, I had the vaccine and I still got the flu." I mean, that actually happened to me one year. I got a type B flu when I couldn't believe it. It was March and I couldn't understand why I was sick. And I went to the doctor and they did a test. It was flu. I said, "Wait a minute, I had the vaccine." Well, it didn't cover B that year. It was only A-type flus. So a lot of people don't want a vaccine. And it's not just flu vaccines, but I feel like flu vaccines, I think I know more people that refuse flu vaccines than anything else. And the other point that you made, which was really interesting, is the subclinical infections with the flu. There was a study that I talk about in my book where they found out that there were people who can have sort of a symptomless flu. And adults too. They're out there spreading the virus. They don't even know that they have it. They don't even know they're infected. I mean, your symptoms can range from nothing to what we usually think of as the flu, where you're miserable in bed with headaches and chills and fevers. So your points were so good. If you vaccinate people, it's going to prevent an epidemic from taking hold. And schools are a great place if the parents would just agree. That's another issue. Other questions or comments?
You had opened with a comment that there's an idea that it had been seeded around the world and it spontaneously started in multiple places. What then is that part of the story? What would have caused it to manifest in multiple places at the same time? What in the environment allowed it to?
I'm going to go back to what, you see, when I was writing my book, people thought that it had started maybe in Spain or something. There's all these rumors about where it started. And then I found this very recent article, and he said that it's, what did he say? He said that it was seeded around the world, and it appeared globally almost everywhere at once. It had been already seeded around the world, silently seeded, obscuring its place of origin. Now, and he doesn't say how or why. He said such early transmission beginning in or before 1918 reached pandemicity on exceeding critical detection thresholds in multiple large urban populations around the globe. So I don't know, how would it have been seeded around the, he said it wasn't the war, because there were people who were, a lot of the epidemics were in troops who hadn't even been sent overseas. It's unclear to me why it would be everywhere in the world all at once. It's just weird. We didn't have the kind of travel we have today. So it's not clear to me, but he said there's no one place, which was a surprise, because my book said it may have started in one of the first places we know about it was Spain, and maybe that's because they didn't have the wartime censorship, and so people were starting to get sick there. But then I see this 2019 paper saying, no, it was everywhere at once. So I wish I could answer that. It was a great question.
In your book, you discuss why you think there was the spike in young adults. Would you care to discuss that with us today?
I think it's still unknown. I mean, the one idea was that very old people, and it's still, the old people part is not very old, but older people. As an older person, I shouldn't say very old. Older people had probably may have been exposed to something similar in a previous epidemic, and so they had some immunity. It's not clear to me why the younger people, the kids, weren't getting killed as quickly as the adults. One idea was that because as I mentioned in my talk, the flu virus elicited sort of a real strong immune response, and the kids might not have had that strong of an immune response. To a certain extent, it's still not entirely clear why it would be the young people, young adults, which is so unusual for a flu virus and kind of hasn't been seen in any recent epidemic. So it's really basically the older people may have been exposed to something, and the kids may not have had as strong an immune response. Anybody else? Thank you so much. You're a great audience. It was great talking to you. Thank you. Thank you. It was good.
Yeah, thank you so much, Gina, for telling such a fascinating story and presenting some very helpful information. So this is sort of a tough act to follow. However, we do have a little something extra up our sleeve for the conclusion of this morning's talk. So I'm sure it wouldn't surprise you to hear that the College of Veterinary Medicine, that we thought a talk like this could give a real shot in the arm to the Purdue's sesquicentennial. And we've realized there's a very practical application of that reality. So at this time, I'm going to ask Dean of the College of Health and Human Sciences, Marion Underwood, and the College of Pharmacy Dean, Eric Barker, to please join me on the stage, and we're going to demonstrate to you an easy but important way to apply this talk this morning as we receive our annual shot, with the help of Purdue pharmacy students. As Dean Underwood and Dean Barker come forward, I want to also explain that right outside of Loeb Playhouse, we have arranged a flu shot clinic that will be available until 2 p.m. So you can take this very personally and get your flu shot today as well. And then, please remember that you're welcome to join us over in Lynn Hall, the home of the College of Veterinary Medicine, for a panel discussion at 1:30 on the topic, the current and future role of vaccination in global health, which will feature the following panelists. Pamela Altonen is a professor emeritus from the School of Nursing. Marifran Matson, a professor and head of the Brian Lamb School of Communication. Suresh Mittal, distinguished professor of virology from the College of Veterinary Medicine's Department of Comparative Pathobiology. And Efremi Syed Ahmed, a postdoctoral research associate in the College of Veterinary Medicine's Department of Comparative Pathology. And also a public reception will follow this afternoon's panel discussion in Lynn Hall. So now I guess it's back to business, and I need to roll up my sleeves.